Very good morning, dear students. We have started the schedule number 2. Today we are going to just revise all the points what we have discussed in the schedule number 2. That is, first we will discuss about motion and its types. Motion and its types. Okay. So already we have first, before going to the different types of motion, let's discuss about the motion. What is the motion? Motion is nothing but when an object is moving, continuously moving with respect to the stationary object. With respect to the stationary object. This is very important. Why I am saying with respect to the stationary object? Then only we can say the object is moving. For example, the best example, see, if we are sitting in the train, and if you look outside the train, we can see the trees, whatever the view we are going to see outside of the train. We will observe that they are moving backside, they are moving backward. Yes or no? They are moving, but we feel that we are at a rest position. So I am telling you with respect to the stationary object. Are you getting this? Then rest, in this one more concept is rest. Stationary, what is meant the stationary object? Now the object will remain rest with respect to the other object. With respect to the other object. Now what is that other object? Other object means what? Stationary object. With respect to the stationary object. Now if I will see that suppose this pen is here only. Now I feel that this is at a rest position. Am I right? This is when I am at a rest position. As I am standing at a rest position, I can feel that this pen is at rest position. Are you getting this? So these two concepts we have discussed in the motion. Then we have discussed the different types of motion. For example, translatory. In that we have discussed about uniform, non-uniform motion. Am I right? So uniform means what? The object which moves in a straight line with the same distance and a same time. For example, the parade of soldiers. Yes or no? The parade of the soldiers which are moving at the same distance and at the same time. So such a motion is called as a uniform motion. Non-uniform motion means what? Which moves in a straight line, but at distance and time, the speed is not a constant. For example, from a boy is moving from the slide. Yes, that child is coming in a straight position, is moving in a straight position, but the speed is changing. So that is non-uniform motion. That is non-uniform motion. Then we have discussed about the circular motion. When object moves in a circular path. When object moves in a circular path, such a motion is called as a circular motion. Along with that, we have discussed about rotatory motion with a fixed axis. When object moves in a fixed axis, such a type of the motion is called as a rotatory. Then we have discussed about vibratory. Vibratory means what? Which gets vibrates. That we have discussed about oscillatory motion. When object moves to and fro. When object moves to and fro. To means what? Front and back. Front, forward and backward. The flapping of the birds. The flapping of the birds. That motion is also called as an oscillatory motion. That motion is also called as an oscillatory motion. Then we have discussed about periodic motion. Periodic motion means what? The motion which repeat after equal interval of the time. The same thing is repeated again and again at the same time. Am I right? So such a motion is called as a periodic motion. Non-periodic means what? Which cannot be occur at a particular time. It can occur any time. So such motions are called as a non-periodic motion. Then we have discussed about random motion. Random means what? Which moves anyhow. The motion which moves anyhow. Such a motion is called as a random motion. Then we have discussed about the last type of the motion, that is compound motion, or it is also called as a multiple motion. When a particular object possesses two or more motion, when an object possesses two or more motion at the same time, such a motion is called as a multiple motion or compound motion. Are you getting this? So these different types of the motions we have discussed in this schedule number 2. Then along with this, there is a second point, that is force and its types. Force and its types. So along with this, there is another point, force and its types. But before that, motion, there are the three laws of motion. Newton's law of motion. There are the three laws of motion which we have discussed. The first law of motion, that it tells you the object will remain at a rest position until any external force is applied to an object. Now this, I have given you the example of the duster. Even this pen is going to remain at a rest position. It is going to remain as it is forever until any external force is applied to that particular object. So this was the first law of an motion. The second law of an motion, that is rate of linear momentum, is directly proportional to the force applied to it in which the direction. That is, I have derived the formula F is equal to m into a. So derivation is not too much important, but you should understand the formula. Force is nothing but mass into acceleration. Force is nothing but force. F, it is denoted by F, and mass, it is denoted by m into acceleration. So force is nothing but mass into acceleration. Are you getting this? So this is the second law of an motion. And third law of motion, every action there is equal and opposite reaction. Every action there is equal and opposite reaction. Then along with this topic, there is one more topic about the force and its types. Let's discuss about that topic, force and its types. So in that first, let's understand force and its types. Let's understand what is meant by the force. Force is nothing but push or pull of an object. Already you know this. This is a simple definition. But force is mainly defined as mass into acceleration. Then we have discussed about which instrument is used to measure the force. Yes, we use spring balance. We use spring balance. So what will be the unit of force? What will be the unit of force? So let's derive the unit of force. As you know, what is the SI unit of mass? Yes, mass is measured in kg. Am I right? And acceleration. So acceleration is nothing but velocity upon time. Yes. Now velocity is a vector quantity. It is a vector quantity. And speed is a scalar quantity. Now speed. Do you know the formula for the speed? Yes. Speed is nothing but distance upon time. Similarly, velocity is nothing but displacement. Displacement upon time. Am I right? So this is denoted, displacement is denoted by small s upon t. Okay? So s, displacement. Now distance is measured. What is the SI unit of distance? Yes, meter. That is m. And time is measured in second. So SI unit of velocity is nothing but SI unit is meter per second. So let's put in this. Now you know acceleration is nothing but velocity upon time. So I will just put here meter upon second, and this time. What will be the SI unit of time? Yes, second. So it will come meter upon second square. This it will come down. So second into second square. So acceleration unit will be meter upon second square. So this kg meter upon second square, this is called as Newton. It is called as Newton. Are you getting? And it is denoted by N, capital N. So SI unit of force is Newton. SI unit of the force is Newton. Are you getting this? Then can you just tell me force is a scalar or vector quantity? Yes, of course it is a vector quantity. Force is a vector quantity. As you know, the instrument used to measure the force is which instrument we are going to use? Spring balance. Yes. So force is a vector quantity. Spring balance, it measures the weight. It shows the direction. So force is a vector quantity. I hope you have understood till this. Now CGS unit. Now let's learn about CGS unit. Now if you will look at force, you know, force is nothing but mass into acceleration. Now what is the CGS unit of mass? Yes, gram. And meter is centimeter. And second square will come as it is. So gram, centimeter, second square is called as dyne. Is called as dyne. Are you getting this? So CGS unit of force is dyne, while SI unit of force is Newton. SI unit of force is Newton. Are you getting this? Then one dyne is equal to how much? Can you just tell me how much dyne? So let's do. I have given you this in your notebook. Now Newton is nothing but kg meter second square. Now 1 kg is equal to how many gram? 1000. Am I right? And 1 meter is equal to how many centimeter? 100. Am I right? I have converted because second square is second square. No issue of this. But kg is converted into gram is 1000 and meter is converted into centimeter is 100. So how many zeros are there? 1, 2, 3, 4, 5. So 10 raised to 5. So 1 Newton is equal to 10 raised to 5 dyne. 1 Newton is equal to 10 raised to 5 dyne. Are you getting this? So this is very important point. 1 Newton is equal to 10. How much dyne we can ask? So it is 10 raised to 5 dyne. Are you getting? So this was an SI unit of the force is Newton and CGS unit of force is dyne. CGS unit of force is dyne. Are you getting this? Then we have discussed about the types of force. But before that we have discussed about the effects of force. What are the effects of the force? Force can change the direction of an object. Force can change the shape of an object. Force can move the stationary object. Force can stop the moving object. These all are the effects of force. Then we have discussed about the different types of the force. There are mainly the two types of the force, that is contact and non-contact. Okay, so contact force means what? Which came in a real contact with that particular object. For example, muscular force. Non-contact means what? The which do not comes in direct contact with that particular object. Contact force there are two main types of the contact force: muscular and frictional force. Non-contact, gravitational, electrostatic, magnetics. These are the non-contact force. So muscular force means what? The force applied by our muscles. Such a force is called as a muscular force. Gravitational force means what? With the help of the gravity, with Earth's gravity. Now in a gravitational force, if you will look at properly, gravitational force, it is what is meant by the gravitational force? The Earth's pull. Yes or no? The Earth's pull is called as a gravitational force. Am I right? Gravitational force. Then we have discussed about the electrostatic force. This is developed due to the electrical charge. So such a force is called as an electrostatic force. Magnetic force means what? Which is developed by a magnet. The force which is developed by the magnet to attract the magnetic substance, such a force is called as a magnetic force. Such a force is called as a magnetic force. Now, in this gravitational force, there is one concept of weight. Now, as you know, what is meant by the mass and the weight? Already in the measurement, we have discussed the two difference between mass and the weight. Mass is nothing but a matter of an object. Mass is nothing but matter of an object, and weight is nothing but a gravitational pull of an object. So, weight formula, the weight is nothing but m into g. M into g. Weight is the gravitational pull of an object. So, mass into the gravity. This is g is nothing but it is called as a gravity. It is called as a gravity, and its value is fixed. That is 9.8. Its value is fixed. That is 9.8. Its value is fixed. That is 9.8. So this is called the g is called as a earth gravity. It is called as a earth gravity. So this value is same. So, and it is also called as a constant. The value is constant, that is 9.8. So weight is equal to m into g. One more important point, if you will look at Earth, the maximum weight we can observe, we can get, if you want to get a maximum weight, the maximum weight is we can get at a poles and minimum at the center. The maximum weight will be, our weight is maximum at poles and minimum at its equator, at the Earth equator. Then, if you will look, a comparison of the weight is done. Then the weight on the moon is 1/6 of weight on the Earth. My weight is 48. So on the Earth, so what will be the weight on my moon? So that is 1/6. So weight on the moon, it will be 6 exa. So 8 kg my weight will be on the moon. Are you getting this? So weight on the moon is always 1/6 of the weight of the Earth. Are you getting this? So this is very important point. Weight on the moon is 1/6 of the weight on the Earth. Are you getting this? Then we have discussed about the frictional force. What is the importance of the frictional force? What are the advantages and disadvantages of the frictional force? That already we have discussed in the force and its types. Then the last point of this lesson is about the, now see, if there are the two objects, they are, suppose if these two panes are there. Are you getting? If these two panes they are near to each other, they are close to each other, they are exerting some pressure on each other. As they are in contact with each other, they use some force on each other. Yes, they apply some force on each other. So this depends on the area, how much they are in contact with each other. Suppose if I will keep my pen like this, then how much force it is going to exert? Or if I will keep my pen like this, then how much force it is going to exert? So this depends on the pressure. So the new concept comes here, that is about the pressure. So pressure is nothing but a force upon area. Force upon area. Are you getting? So what will be the SI unit of force? Let's SI unit of pressure. Now can you tell me what is the SI unit of force? Yes, Newton, and area meter square. Am I right? So SI unit of pressure will be Newton meter square. Newton. SI unit of pressure will be Newton meter square. This is also called as a Pascal. This is also called as a Pascal. It is not a fundamental quantity. Pressure is a derived quantity. Because why we can say derived quantity? Because they are derived from particular object, or we can say particular quantity, different quantities. Are you getting? So they are called as a derived basic quantity. So they are called as a derived quantity. Are you getting this? I hope you all things you have understood it. If you will have any doubt regarding this, and if you have learned the new points, please note down in your physics notebook. Okay, I hope you all have understood it. Still, if you will have any doubt, you can ask me on my personal number, or you can call me. Okay, thank you.